Uh, Good morning, everyone. Still good morning. We will continue this week, inshallah, on the matrices, the topic that we introduced previously this week. I will start from the inversion, how to get an inverse for a matrix. It's supposed to be really very simple. Marwan, المرة اللي فاتت احنا خدنا practical rule. خدنا how to get an inverse of a matrix using empirical rule. Okay, no. Okay, if you remark for the operations that we did go through in the previous part, we took how to define a matrix, how to do addition, how to do multiplication, and we know that we can do multiplication either by multiplying a scalar value or by multiplying two matrices. The thing that we didn't go through yet is inversion. I believe we took some of the properties of inverse in the previous lecture. But how to do the inverse exactly, or how to get the inverse of a matrix, we will see together. I will start by 2 by 2 and 3 by 3 matrices. In general, you can't get an inverse of a matrix unless it is a square matrix. What we mean by square matrix? The matrices which has the number of rows equal to the number of columns. Okay, each one of these, it's called a row. And each one of the vertical numbers, it's called a column. So this contains 2 rows and 2 columns. For this one, it's 3 rows and then 3 columns. Okay, we need to start first how to get the inverse of this 2 by 2. It's very, very simple. So if I start with A, let's say A is equal to a matrix of 5, 2, 3, and 1. The first thing that you should do is to get the determinant of this matrix. How to get a determinant of a square of a 2 by 2 square matrix? This is step number 1. Getting the determinant of A, which is very, very simple. All I have to do is to multiply the elements of the principal diagonal minus the elements of the secondary diagonal. معايا مروان? So it's gonna come up to 5 times 1, those 2 elements, which is the principal diagonal, minus the secondary elements, which are 3 times 2, which is gonna come up to 5 minus 6, which is gonna be negative 1. What's really matter is that this value doesn't equal to 0, because once the value of the determinant is equal to 0, we will have what's called a singular matrix. For the matrices where its determinant doesn't equal to 0, we call them non-singular matrices. Non-singular matrices, it means the value of the determinant doesn't equal to 0. Once the value of the determinant doesn't equal to 0, it means we can get the inverse of this matrix. Okay, so this is first step, check. We can do it. Step number 2. I will start by writing the cofactors. How to get the cofactors of a 2 by 2 matrix? Remark, I will start writing the elements A11. Then I will write A12. I usually feel more comfortable doing this. A21. Then A22. So if you remark, these elements are elements of a row, but instead it is written as a column. How did you know that it is a row? The first number, as you can see, is 1, which means this stands for the first row. And those numbers stand for the position in a column. So those are the elements of the first row, but it is written in a column form. This same way like, those are the elements of the second row. How did you know that it's the second row? The first number is 2, but it is written in a column form. Then I will do equal, 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 equal. زياد انت فاكر الساين رول كان بتقول ايه بتاعت الماتريسيز؟ كنت بستارت with positive, negative, positive, negative. كمان انا عارف ان كل نيجاتيف ساين يا فيصل لو أنا جبت the sum of these two numbers and it was even, it's going to be positive. But if you get the sum of these two numbers and it is odd, the sign will be negative. So I will start now with writing the sign. So it's a positive, then negative, positive, then negative sign. Then how to write these cofactors, جماعة؟ ازاي بطلع cofactors? It's really very simple. I will go for the element 1 1. This is the element 1 1. Eliminate the row and column. The remaining number, write it. So I will eliminate the first row and the first column. What's gonna be? 1. Then I will go for the element 1 2. This is first row, second column. Eliminate these row and column, and the remaining is 2. I will write it down. Nada. I will go for 2 and 1. This is second row, first column. I will eliminate both of them. The remaining will be 3. I will go for 2 and 2. Second row, second column. I will eliminate both of them. The remaining will be 5. This is what's called the cofactor, or the factors of the determinant. I will go at each position, eliminating row and column at this number, and will write the remaining part. After we do this, I will get them all in what's called the adjoint matrix. So I'm going now to evaluate or to put the adjoint matrix all together. I will get all these numbers, which are 1, -2, -3, and finally 5. Fourth step and the final, say that, I will get A minus 1, which is simply 1 over the value of the determinant of A times the adjoint matrix, which will lead to A minus 1 will be, I will divide all those elements on the value of the determinant, which is -1. So it's going to come up to -1, 3, 2, and -5. That's the inverse of this matrix. The inverse time matrix. يبقى تاني. How many steps? Mainly 4 steps. The first of them is to get the determinant assigned to this matrix. If it's equal to 0, we can't proceed. As you saw, at the end of these procedures, we divide on the value of the determinant. So mainly it makes sense. If the value of the determinant equal to 0, you are not going to be able to do this division. Okay? So the first step is to get the value of the determinant. It doesn't equal to 0. It's called the non-singular matrix. So I can get its inverse. The second step, I will start writing the cofactors. How to get the cofactors? Start identifying for each element, eliminating the row and column, and write the remaining number. Don't forget to put the sign rule. The sign rule starts with positive, then negative, then positive, then negative, and so on. You can move as zigzag, as we saw in the previous lecture. Then, finally, I will put them all together, which is the adjoint matrix. Okay, dividing on the value of the determinant, I will be able to get the inverse of this matrix. There is another method, which is the empirical method. Usually I use it, we will use it, for a 2x2 matrices. دايما نستخدمه ل 2x2 matrices. Okay. تعال نشوف ازاي اجيب for 2x2 matrices.
طب دكتور عندي سؤال.
لا استنى. لو انا عندي بص كده A, B, C, and D. That's a matrix 2x2. I can get its inverse directly without all of these steps, just only for the 2x2 matrices. It's very, very simple. All I have to do, I will get A minus 1 equal to 1 over, try to get the multiplication or the evaluation of the determinant. So it's going to be AD minus B and C. I will multiply the elements of the principal diagonal minus the elements of the secondary diagonal. Then, I will change the position of the elements on the principal diagonal. So it's going to be D and A. Then I will change the sign of the secondary diagonal. It's going to be like this. So once more, this is a very fast way to get the inverse. اوكي مش فكره الاسهل، هو الفكره ان الستبس دي we will use it to evaluate the inverse for a 3 by 3. So it is easier for you to understand them first on 2 by 2, then we will apply it on 3 by 3. This method, of course, it's similar, okay? But it is applied only for a 2 by 2 matrices. معايا فيصل؟ طب تعال نجربها. تعال نجربها. نشوف هنجيب if are we going to get the same matrix or not. Okay, really very simple. Take matrix A, here we go. That's matrix A, and I will get its inverse directly. A minus 1 will equal to 1 divided by 5 times 1, it's gonna be 5. Minus 6, open your bracket. Here we go. Interchange the position of the principal diagonal. So it's gonna be simply 1 and 5. Then change the sign of these, of the sides, of the secondary diagonal. So it's gonna come up to negative 3 and negative 2. Do the multiplication. This is going to be 1 over negative 1, which means you will multiply all the elements by negative 1. So simply, a minus 1 will be negative 1, 3, 2, and the negative 5. Look at these two matrices. They are exactly the same. Okay? How to be sure that the matrix that you got is an inverse for the main matrix? How to be sure about this? If I multiply it in the original matrix, the result will be unit matrix. So, this is the only way to get or to be sure that these two matrices are the inverse of each other. So, how to do this? I will multiply these two matrices. I will show it to you. Just to be sure that's the inverse of these two matrices. So, the first one simply is 5, 3, then 2 and 1. The second one is negative 1, 3, 2, and negative 5. Let's multiply them together. So once you start multiplying, I will multiply the first row by the first column. Let's do it. 5 times negative 1, it's going to be negative 5. Then plus 3 times 2, which is going to be 6. Negative 5 plus 6, so the result will be 1. I will multiply the first row by the second column. So it's going to be 5 times 3, which is 15. Then 3 times negative 5, negative 15. 15 plus negative 15, the result will be 0. Of course, what's your name again? Silay. Yeah. Okay. Miss Silay, I'm multiplying the row by the column. So I will multiply 2 times negative 1, which is negative 2. Then plus 1 times 2, so it's going to come up to 2. Add them together, the result will be 0. Okay, so it's going to be 0. Same way like I will multiply the second row, okay, by the second column. So it's going to be 2 times 3, which is 6. Plus 1 times negative 5, negative 5. 6 minus 5, you will end up having 1, so it's already a unit matrix. We are sure it is the inverse. Identity matrix. Okay, perfect. يبقى إذا في الوقت الراهن أنا عرفت how to get a 2 by 2 matrix either by the cofactor method or by the empirical rule. طيب نفس الستبس دي أهي once more. The first step, this is your matrix. So I will get the determinant, which is simply 5 times 1 is going to be 5, minus 6, so it's going to be negative 1. Then I will start by eliminating the row and column at each corner. So element 1, 1, which is 5, I will eliminate the row and the column. The remaining 1 is 1. Here we go. I will go for 1 and 2, which is 3. I will eliminate the row and column. The remaining number is 2. Here we go. And so on for the rest of the numbers. I will put the sign rule, which is positive, negative, positive. I will write these values together, here we go, and divide them on the value of the determinant. That's the inverse that we are targeting. Same procedure will be done, but, and this is of course the empirical rule, for the 3 by 3 matrices. But in 3 by 3 matrices, we will have to evaluate first the determinant, How many methods we took for evaluating a determinant for a 3 by 3? Two of them. Either Gauss rule or the Saras rule, if you remember in the last lecture. So I will do it with Saras rule. Let's do this for the 3 by 3 determinant. طبعا خلي بالك ان الجزء ده this is really the easiest part and till the time being. This is very, very simple. It's a direct steps. You are eliminating, evaluating the value of the determinant and getting the value of the inverse, which will be very, very important down the road. Okay, let's do it once more. I will start with getting the value of the determinant of A. Yesterday, we took the Saras rule for evaluating the determinant for a 3 by 3, which is really very simple. All I have to do is to multiply the elements of the principal diagonal. So I will do 3 times 1 times 1. Let's do it. 3 times 1 times 1. Then plus. Remark that the principal diagonal divide this square matrix into upper triangle and the lower triangle. Can you see them? Okay, so that's mainly the principal diagonal. That's the upper triangle and that's the lower triangle. I will multiply the elements of the base of the upper triangle and the head of the lower triangle. So it's going to be 0 times -1. Then plus, vice versa. I will multiply the base of the lower triangle and the head of the upper triangle. Do them for me. Okay, 0, 0 times 0, then times -1, then plus 2 times 0 times 4. I will do all of this once more, but within the negative direction or the secondary diagonal. So I will do them starting from 4 times 1 times -1. Then 0 times 2 times 1. Then 0 times 0 times 3. Okay, let's do them. فيصل اوكي؟ مهاب اوكي؟ كله تمام؟ انا مركز معاها في ده علشان ده احنا خدناه المره اللي فاتت. Okay, start. It's gonna be 4 times 1 times -1. Then plus 0 times 0 times, okay, 3. Am I right?
Yes.
Okay, then plus 0 times 2 times 1. And it will equal to. Let's evaluate it. معايا بالسيدة؟ طبعا 3 times 1 times 1 is gonna be 3. This is gonna be 0. That's gonna be 0. So all I have now is just simply a 3 positive. Minus. Then I will have, those are 0, 0 also, but this guy is -4. So negative times negative is going to be positive of a 4, so the value of the determinant is 7. And this is how we evaluated the value of a 3 by 3 determinant. Of course, it's not equal to 0, which means it's a non-singular matrix, so we can get the inverse. I will start by writing or getting the cofactors. معايا مس ندى؟ I will start with A11, then A12, then A13, which are elements of a row, but it is written in a column. I will start with the second row, which is A21, A22, A23. Then I will get the elements of the third one, which is A31, element A32, and the element A33, equal to, and so on. I will start putting the sign rule. The sign rule starts with positive. Then it will go negative, positive, and so on. So I will start positive, then the sign here will be negative, positive, then I will move negative, positive, then it's gonna come up to negative, then I will move positive, negative, and the positive. And it's really simple, just to check. If you get the addition of these, the sum of these two numbers, if it gives you an odd number, it should be negative sign. Even number, it should be a positive sign. So whenever you check, you will find the negative sign in front of the elements where I plus j is an odd number. Then I will start the elimination. Eliminate with me. For the number A11, which is 3, eliminate the row and column. Eliminate the row and the column. The remaining numbers are?
1.
Okay, give them to me.
1.
هيديني 1 0 0 and 1. For element 1 and 2, eliminate the row and the column. I believe it's gonna be 2 negative 1 0 and 1. Am I right? Eliminating the element of the rows and columns of the element 1 2. This is 1 2. So I will eliminate this guy and that column. You will end up having 2 negative 1 0 and 1. Here we go. 2 negative 1 0 and 1. I will go for the element 1 and 3. معايا Mr. Faisal? Then element 1 3. I will eliminate the row and the column. The remaining will be
3
2
4
negative 1 1 and 0. Okay, I will go for 2 and 1. Second row, first column. Second row, first column. Eliminate both of them. The remaining numbers are 0 and I need 2 and 1.
2 and 1.
0. Then I will have 4. Then I will have
1. 0
0 and 1. I will go for element 2 and 2. Can you give it to me?
3
أيوة.
4
Yep.
negative 1 1.
Okay. I will go for element 2 and 3. Where is element 2 3?
2 and 3.
Second row. Yes, exactly right. This is second row, third column. So it's going to be 3 0 negative 1 and 0. Okay. 3. Okay. 3 0 0 and the negative 1. I will go for the third row first number. The first row first column. So you will have 0 4 1 and 0. I will go for 3 and 2. So you will end up having 3 2 4 and 0. أي مشاكل? Any problems? 3 by 3. So you will have 3 2 and double zeros. Of course, any determinant that has a row or a column with zeros, the value will be 0. Okay? طيب, start. The first number is 1. The second number is 2 times the negative. You say negative 2. The third number, it's going to be 0, then minus negative 1, which is going to come up to positive 1. For this guy, I will have 0 and 0. So it's going to be 0. For this number, it's going to be 3, then plus 4. So it's going to come up to 7. This is going to equal to 0. For this one also, it's going to be 0, but minus 4. Okay? The last one, 3 times 0 is equal to 0. Then minus 8 times the negative, which is going to be 8. I will check that later, and this value is equal to 0. Let's check them. 2 times 1 be 2, negative, it's going to be negative 2. Same way like this is going to be negative times negative is going to be positive. For this one, it's going to equal to 0. This is going to be 3 plus 4, which is going to be 7. This is going to be 0, it's okay. For this guy, so 3 times 0 is going to be 0. This is minus 8 times negative, so it's going to come up to 8. This is negative 4. Okay, we are all good. Now I have the numbers. I will put them all in the adjoint matrix. Now we have an adjoint matrix, which is 3 by 3. Gather these numbers. So these numbers are 1, negative 2, and 1. بعدين 0, 1, and 0. بعدين finally we will have negative 4, 8, and 0. That's the A adjoint matrix. How to get the inverse? I will divide all these numbers on the value of the determinant. So it's going to come up to 1 over 7 times the a adjoining matrix, and that's the inverse of this matrix. So all the elements will be divided by 7. Once more, get the determinant as we saw. It's going to be 7 not equal to 0, it's a one singular. Stop by getting the inverse. Now we can eliminate, that's the sign rule. So I will start B11, B12, B13, same way like B21, B22, B23, and so on, B31, B32, and B33. B33 it's a 3021. احنا قلنا ايه هنا؟ يبقى في هنا رقم لما انا عملت دول ده 3 و2 ده 0 وده 1 يبقى النمبر ده 1. اوكي زي ما حضرتك شايف. اوكي next step I will write them all together. يبقى اذا ده الماتريكس بتاعتي. بعدين I will divide all the elements on 7. That's the inverse. How to check it is true? If you multiply A by B minus 1, B by B minus 1, so the result will be unit matrix. تمام يا شباب؟ طبعا this method it's really very simple but it has a problem. The main problem with this method, if you have a dimension 4 by 4, it's not gonna be easy to evaluate.
Long.
Because the number of matrices that you will have to handle, it's a huge number of matrices. And that's the obstacle of using determinants in solving or analyzing a system of equation. معايا Mr. Muhab? Okay. Now we will get back to the main slides once more of Lisbon. Now I want to talk with you about the conjugate matrices. In the previous lecture we talked about transmoses. Transmoses means you will change the rows into columns or vice versa. The conjugate matrix, it is related to the complex numbers, and in general, any complex number will be a number and it contains a real part and an imaginary part. Any number, any complex number, which is gonna be on the form A, positive or negative, or let's start by A positive, okay, I times B, which is a complex number. It contains a real part and an imaginary part. For each complex number, there is its adjoint or conjugate number, which actually be on the form A minus IB. That's the conjugate of this value. So if I have 1 plus I, the conjugate will be 1 minus I. If I have 2 minus 3I, the conjugate will be 2 plus 3I. If I have 2I, then the conjugate will be negative 2I. If I have 5, the conjugate will be
Negative
5. No, 5. There is no conjugate, or the conjugate for numbers, it will be the same. So, for the real numbers, there is no conjugates. So 2, its conjugate is 2. But for the negative numbers, negative 3i, it's going to be positive 3i, and so on. معايا say that? Okay, very good. We will assign the conjugates for matrices by a dash above the matrix. So, Ms. Nada, if I have AB belongs to the set of matrices M by N, which contains M rows, N columns. And it is a matrix with complex numbers, because C stands for complex numbers. Okay, C belongs to N by B. So it's an N rows, P columns. And the alpha is a scalar value. Baby, it belongs to the complex set. Then, if I have A conjugate, it will regain its main value. So if I have an A matrix and I get its conjugate, and then changing once more to another conjugate, it will regain its main form. طيب خليني قبل ما اتكلم في ده كده, let's see this example. 2i minus 5i 3 or negative 3. This matrix is called A. How to get its A conjugate? Or what is the shape of the conjugate of this matrix? Nada. it will be 2, then negative I, then minus 3, and for this element, it's gonna be 5 over 9. If you change this once more, you get the conjugate again once more, so 2 will remain 2. Negative I will be I, negative 3 will be negative 3, 5I. Once you get the conjugate once more, it will regain its shape. Okay, if you have two matrices added together, then you get its conjugate. It's exactly the same like getting the conjugate of each one of them, then performing the addition. If you multiply alpha times a conjugate, it will equal to the conjugate of the constant times the conjugate of the matrix. If I have A times C conjugate, it's going to equal to A conjugate times C conjugate. Remember, this property, it's really very important. Because if you have A times C, okay, it's not going to equal to, okay, if I have A times C to the power of negative 1, for example, it will equal to C minus 1 times A minus 1. If I have A times C and I'm getting a transpose, it's going to be C transpose times A transpose. But in the conjugate, case, it's going to be the same. AC conjugate is going to equal to A conjugate times C conjugate. Are you with me? واخدين بالكم معايا? This is very, very important. M equal to N, then if I have A to the power of K, and I'm getting the conjugate, so A conjugate to the power of K, they will be the same. If M equal to M, that means the rows equal to the columns, it means square matrices. So it's vice versa, A is invertible, then A conjugate is also invertible, which means A conjugate, negative 1, equal to A negative 1, then getting the conjugate of this matrix. Okay, A conjugate transpose equal to A transpose, then getting the conjugate of this matrix. Remark, we have an inverse. The probabilities of the inverse already exist in the previous lecture. If you remember, we started by the probabilities of the inverse. Then we took the transpose properties. Then we took the conjugate properties. The three of them are really very important. Okay, once more, يبقى معايا في الديفينيشنز. طبعا خلي بالك ده الكونجيجيت ترانسبوز. لو انا عندي ايه كونجيجيت واجيب لها ترانسبوز زي الايه ترانسبوز واجيب لها كونجيجيت. طبعا دوت E1212 اللي بالريد لما بعمل ترانسبوز I will change the rows to be columns and vice versa. ماشي؟ say that. Hey, it's me. You're new. Sitting. You are sleeping. Okay? So try not to sleep. شباب لما بجيب conjugate وترانسبوز بدي ساين للستار دي. بحط الساين بتاع الستار دي. يعني لما بعمل how many process 2 يعني لو عندي ماتريكس اسمها ايه؟ جبت لها first transpose. Then I will try to get the conjugate of this transpose. يبقى how many process I did? 2 of them. Getting the transpose first, then getting the conjugate. Okay? This is A star. Remark, this is really important. A matrix A is Hermitian. يعني ممكن في الامتحان يقول لك in the given matrix in the exam in our midterms, it's going to be MCQ questions. I spoke with them in the previous lectures about that. I don't know if you went to the YouTube channel for the recorded lectures or not yet. But after we finish, I will show you the lectures that we took previously. And it's really very important to go through them, okay? Like this one, we are recording, and I will raise it on the YouTube to be with you down the road. Okay, this is one of the important definitions. Usually it came in the previous exams, okay? Most of the exams, they brought this part. The Hermitian matrices are the matrices with, or those types of matrices with a very unique property, which is when you get the transpose and the conjugate of the matrix, it will regain its main shape. It will equal to its main shape. So remark that A equal to A star. What we mean about A star say that? The transpose then the conjugate. So if you have a matrix, you get its transpose, then you get its conjugate, you will find that it's equal to the main matrix. So the Hermitian type of matrices are those ones where the matrix will equal to the transpose of the conjugate or the conjugate of the transpose. In other words, Aij, any element in this matrix, will equal to AGI, which is the transpose, dash with conjugate. Okay? تمام؟ معايا؟ فيصل اوكي؟ طبعا طالما انا عرفت دي في حاجه اسمها skew Hermitian. As long as we know about this, we will see also the skew Hermitian matrices. Let's remark these matrices. The first one of them, which is simply 1 plus 2 plus 3i, 2 minus 3i and 5. بص كده مستقبل. For this matrix, which is 1, 2 plus 3i, 2 minus 3i, then 5. First, get the transpose. مديني transpose كده يا ندى. Transpose of this matrix. ايه هو انت بتتكلمي لورا؟ علي صوتك. ها؟ 1. Change the first row to be the first column. ها؟ 2 plus 3i. ها؟ صوتك حلو اهو. 2 minus 3i then 5. يبقى اللي انا جبته ده لو A، انا كده جبت A transpose. Are you with me? Okay. I want you to get the conjugate. رحت فين؟ I want you to get the conjugate of this transpose. يلا. A transpose وهجيب لها conjugate. هيدمن ال1 هو صح؟ بس 2 minus 3i هتبقى 2 ها؟ plus 3i. طب وده؟ 2 minus 3i وده؟ وريمين